Hello friends, welcome to my channel. Welcome to Daily Code Challenges. I'm so excited to be here and I hope you are as well. Okay, we have another very interesting challenge today. Today being day 19. But before we move to that, let's have a quick recap on what we did yesterday. All right, yesterday we wrote a function called is perfect square that accepts an argument, right? And this returns a boolean indicating whether or not the argument is a perfect square. So how do we even know what perfect squares are? What's a perfect square? When a number multiplies itself, the result it gives is simply a perfect square. So when 4 multiplies itself, we have 16. That makes 16 a perfect square. Other perfect squares are 25 because 25 is a product of 5 multiplied by itself. 36 is a perfect square. All right. 49 is a perfect square. That's 7 times 7. All right. So we wrote a function that could actually tell if a number is a perfect square or not. If it is, it returns true. And if it's not, it returns false. All right. Having that said, let's move to today's code challenge. So I just closed day 18. All right. So this is what we have for day 19. Let me zoom in this a little. All right. Day 19, it says Fibonacci, right? The Fibonacci sequence is a sequence of numbers whose first and second elements are 1. To generate further elements of the sequence, we take the sum of the previous two elements. For example, the first 6 Fibonacci numbers are 1, 1, 2, 3, 5, and 8. Here, we are expected to write a function called Fibonacci that takes in a number length and returns the Fibonacci sequence up to the given length. Now, looking at the function examples here, when invoked, it says that if we pass in an argument of 0, we should get an empty array. If we pass in an argument of 1, we get an array with just one item inside, which is 1 itself. When we pass in an argument of 6, we have an array with 6 items. These 6 items, they represent the first 6 values in the Fibonacci sequence, which are 1, 1, 2, 3, 5, and 8. And then when we pass in an argument of 8, we have 8 values, which are the first 8 values we have in the Fibonacci sequence. All right. Now, how do we solve the Fibonacci sequence? How do we solve, or how do you write a function to get these when a parameter is passed in? Looking at this, let's take line 12 for instance. Line 12, we have 1 as our first value and then 1 as the second value. To get the third value, we need to sum the first value and the second value to get the third. To get the fourth, we need to sum the second value and the third value to get the fourth. To get the fifth, we sum the third and the fourth, right? So that's how we are going to solve this. How do we use that in the code implementation? To use that in the code implementation, we need to understand one thing, that to get a particular value in the Fibonacci sequence, we have to subtract the index of the previous value. We have to subtract the index of the previous value from the index of the current value we want to work with and sum it with the index of the previous one before the previous. So what that means is that let's move to the code implementation and see how to arrive at this. So we start using the function keyword. We remove name because name is not the function name. Fibonacci is the function name. So we change this to Fibonacci. We can use params as the parameter, but I choose to use num. Okay, so when we look at this very well, on line 3, it explicitly states that the Fibonacci sequence is a sequence of numbers whose first and second elements are 1, right? That means that the first element is 1 and the second element also is 1. And also it states on line 13 that when we pass in an argument of 0, we should get an empty array. When we pass in an argument of 1, we should get an array with just one value, which is 1. So we are going to solve this first. We use a condition. We say if parentheses then curly brace, if num, which is a parameter, is equal to 0, let's return an empty array, which is this. So we return an empty array. Then we say else if parentheses curly brace, we say if num is equal to 1, then we should return here not an empty array, but an array with a value inside 1, right? Okay, so we save this. Let's call these two functions and see if the code implementation is correct. So we comment this. Sorry, we remove the comments of this. We save again. Let's run our code. Okay, so I'm going to clear this, and then I'm going to run. All right. So we have the empty array when 0 is passed as an argument, and also we have an array with just one value inside, which is 1 itself, when 1 is passed in as an argument. All right, so we've been able to satisfy these two conditions which we implemented here. Now, how can we get other values being passed into the array when an argument is passed into the function? That's the next thing we want to do now. Let me close this part, and here we need to look through some values, right? Since we've been able to get the first and the second value, which has been stated here, it says whose first and second elements are 1. Therefore, we are going to explicitly assign 1 for the first value and 1 for the second value. So we come here and say let array equals 1, 1, because we understand that the first two values of a Fibonacci sequence are 1 and 1. Therefore, we say 1 and 1. We save this. The next thing we want to do is want to write a for loop. We say for. Now, what this for loop does is that this is going to help us to loop from this second part, which is a second index, because this index 0, index 1, index 2. From this second index, and then stop at whatever index we need to stop at, depending on the argument that is passed in the function. For instance, now we pass 6 here as the argument. That means that we are expected to have 6 values in the array. Here we passed in 8 as the argument. We got 8 values in the array, right? Now, one thing we need to also note is this. When we pass in 6, we have 6 values. That means the index is going to stop at 5 because we have 6 values. 5 in the sense that JavaScript is an index-based number, is an index-based programming language, and we start counting with 0, 0. So this means 0, 1, 2, 3, 4, 5, because we passed in 6 as the argument. If we passed in 8 as the argument, our index is going to be 7 because we are counting from 0. We have 0, 1, 2, 3, 4, 5, 6, 7. All right. So here now we simply remove this line of code. We don't need this. And I'll change my index to I. Change this here also to I. Change it also here to I. Though we can actually leave it as index, it's going to work well. Okay, let me leave this as index so that it shouldn't look like it's only I we've been using. We don't need array.length here. So here now, we want our index to start from 2 because we already have the index 0 and we also have the index 1. Therefore, we should start from index 2. And then index should be less than num. Num represents the argument you are passing in the function, like I mentioned. So if you pass in 6, index should not be up to 6. It should be 7 so that we can, it should be 5 rather, so that we can count from 0 index to the 5th index. All right. The next thing we want to do is we are going to say array, which is the array we actually have here. Array I, that's the current index we are working with, is equal to array I minus 1 plus array, not I, sorry. Okay, right. So here now we are using index, not I anymore. So array of index equals array of index minus 1 plus array of index minus 2. Let me explain this part, this line 17. What it means is that this array index, for instance, using line 25 as the case study here, array index here simply means an index in this array, right? Let's assume that 5 is the index we are working with now. To get 5 here, we are going to say the array, the index of 5, which is 0, 1, 2, 3, 4, that's the array of 4, is equal to array of 3 plus 2. And how do we get 3? That's the array of 5 minus 1. That takes it backward one time. That means we get 3. If we say array of index minus 2, that means we are going backward 2 times. 1, 2. Then we hit 2. That means it's going to be 2 plus 3 equals 5. Similarly, here we have 3 plus 5 equals 8. Similarly, we have 5 plus 8 equals 13. 8 plus 13 equals 21. So this stops us at 21 because we said index is less than num, right? So I save this, and the next thing we want to do is we want to return this array because the values we actually get here, they are assigned to array index, which gets added to this array. That's why we actually use let, not const. If we had used const, we won't be able to change the data we have here. So we use let, right? So we return array. Let's hit the save and let's run again. Okay, we still get empty array and 1. That's because we commented this. Let's uncomment this part of the code and let's clear this console. All right, so I'm going to save this again and then run. Okay, let's see if we got the implementation right. When argument 6 is passed into the function, we have 1, 1, 2, 3, 5, 8. Let's check. 1, 1, 2, 3, 5, 8. Awesome. When argument 8 is passed into the function, we have 1, 1, 2, 3, 5, 8, 13, 21. Here we have 1, 1, 2, 3, 5, 8, 13, 21. Awesome, awesome. So we've been able to implement the code for this challenge called Fibonacci, and I must confess it's a very interesting one and a bit tricky, right? So that's all for now, and I'm very happy you're able to join today's class. Thank you very much, and hope seeing you in tomorrow's class as well, or in tomorrow's session rather. So thank you very much and have a wonderful time. Bye.